And here we are again, the trifecta. Because everybody loves a bit of light, don't they? I've had so many comments over the last couple of days, right? Some on the pyramids. Like, have you not worked the pyramids out yet, mate? It's like, seriously? I have actually worked them out. I don't think people are actually paying attention to what I'm saying. Something really strange is going on. Anyway, for another time. This would be the sun, okay? It's got all the colours in it. Yellow, it's like white now. Put some yellow, pink, orange, then back to a bit of pink. Doesn't really matter, does it? Light. 299,792 kilometers per second, right? This is the speed of light. I don't like it. Right, Roma was first. We're not doing it. Roma. The little accent. Bradley. Aberration. Sweet so. No beam of light can travel 16 kilometers before electricity came out. That's why all of the first three and the rest are all the same. None of them have a specific way. It always says, and then he tripped up and he was able to work out the speed of light. It's always something like that. Never adds up. None of them do. Then we've got the diameter of the sun, right? Which is 1,390,000. We all know this. If we divide the diameter of the sun by the speed of light, we get 4.6. So put it up there. 4.6 seconds. What this means is it takes 4.6 seconds for the sun to radiate light the distance of its own diameter, right? 4.6 seconds. Light, its diameter. It's ridiculous. It's way too slow, it's illogical. So what we've got, this is just a little common sense look at things as well, right? It's not all about all the science and the numbers, and it's not always about that. I know. People get a bit funny when I say common sense, but I tell you what. Right. I'll do that after. Mercury, right? We're 150 kilometers away. It takes 8 minutes and 20 seconds for the light to reach us from the sun. Mercury is only 53 million kilometers away, all right? Alexa, what's 53 million divided by 299,792?
53 million divided by 299,792 is approximately 176.7892.
176, all right? So we call it 176. Now, we just divided 53 million kilometers by the speed of light. The same as we do with the diameter of the sun. We've just done it with the distance that Mercury is away. It's 176 seconds. So it's 3 minutes, all right? 3 minutes. The first planet, Mercury, right? It's only 53 million kilometers away from the sun, right? And they're saying that it takes 3 minutes for the light to travel this distance. 53 million kilometers. The sun's diameter is already 1.3 million, all right? It's 1.3 million diameter. How is it going to take 3 minutes to just travel 53 million kilometers? This is the bit that people are missing. It's taking the sun at 299,792 kilometers per second. It's taking the sun 4.6 seconds, right? Like there, right? Forget Mercury at the moment, this is just a sun thing. It's taking 4.6 seconds for the sun to radiate light the distance of one of its diameters. So it's got 1 second, 2 seconds, 3 seconds, 4 seconds, 4.6 there. How is it even possible that something the size of this is taking 4.6 seconds to radiate light from itself, its own diameter? Blah, blah. Because that's what's happening. It's illogical. It is so illogical. Surely people can see this. Right, so it's going to take 3 minutes for light to get, if it turns itself on in the morning, all right, come on sun, boom, 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 all right, lights on, 3 minutes, 3 minutes. No, all right, doesn't happen. And they're saying that if you were on Venus and you were looking towards the sun and the sunlight was headed towards Mercury, you wouldn't see it. How are you not going to see the sun if it's all of these things, right? It's ridiculous. How are you not going to see it? We see Saturn straight away. If you know where it is, you go like this, bang, 1.4 billion kilometers, just like that. But you're not going to see the sun that's only 150 million kilometers away. It's ridiculous. It's actually getting quite annoying, right? And then, so it gets to Mercury, and it takes another 3 minutes to get to Venus, right? So it's been traveling for 6 minutes this way, right? It's still got 2 minutes and 20 to go, but you're telling me that we still wouldn't see it. Oh. It gets to us, right? And everybody's happy, 8 minutes and 20. Everybody thinks, yay! But it's not. Oh, sorry, and we've got Mars at the end. Sorry, Mars, another 5 minutes, right, for light to get to Mars. The methods that we used to work this 299 out are all bogus. None of them add up, right? The sun's light is absolute, right? And we know this. It's a very simple exercise. Very, very simple exercise. It's a ball. It's a sphere, isn't it? It's a sphere. Boom. Boom. Basketball court. There'd be a shadow down there, wouldn't there? You know what, I was going to go into this so many different ways, but it's getting to the stage where let's just go to the field. Let's just do it. I don't know what's going to happen here, but we're going out into the field, so it might get a little bit bumpy. Just hang on. All right. See, I can't even see what the planet. me zoom out. Zoom in. Right, zoomed in. Right, we're good. I'll do a quick walk. Just make sure everything's tip top. Right, plan to there. You know what? So what we've got Mercury. Why are you not picking it up? What's going on here? Oh, it's there, right, I'm gonna... So we've got Mercury, Venus, Earth, and then quite a little bit further away is Mars, and then Jupiter, and then right at the end we've got Saturn and its rings. Now, if this was to scale, and the Sun switched itself on, they say that it's going to take an hour and 20 for the sunlight to reach Saturn, right? 1.4 billion kilometers. So it's logical. Light of the sun is absolute. So what I'm going to do now, I'm about to turn the lamp on. Now let's see what happens. And then I'm going to zoom in and turn it on. Here we go. So I'm going to get down my knees, right? And this is just a little 60 watt or 40 watt bulb. Yeah. Please don't fall off of the tripod. Please don't fall off of the tripod. Come here, lamp. Come here, lamp. That's a good lamp. Come on, keep. Nice. All right, so So we can see all the way down to Earth there, can't we? If we zoom in. That's maximum zoom. So behind Earth, you could just see Mars. See Mars? And behind Mars is Jupiter. See what the point is, right? Yeah, but it's only a bulb. It's only a bulb. If it was the sun with a diameter and this was to scale, like back out to 1:1, the sun would cream it. Now this is, don't forget the sphere thing. The sun is a sphere and it's taking 4.6 seconds for it to radiate light the distance of its diameter. It's ridiculous. But that is what I mean by absolute. It's on and it lights up. Now let me go and get this other contraption out. This is what this was all about. Actually haven't checked. Looks right. We've got to picture the sun. It's not an experiment, it's the sun. It does not take time. Right, here we go. Looking down there. And this is absolute. Look at that. You can see Saturn and its rings. Can you see it? I put foil, tin foil. You've got Jupiter, the orange, and right behind it is Saturn. See the rings. See the difference? The more powerful something is, the further its light will go instantly. No travel time. There's no travel time to talk of. If something is not that powerful, its light radiates instantly to as far as it can go. Right? If this had been the sun, it would be 4.6 seconds every diameter. It is not logical. And this is absolute. This is what the sun would be like. Boom. Light, instant, everywhere. Sun's light is absolute. It doesn't need to go much longer than this. I need a couple of days off. I really do. Well, it's been fun, peeps. I'll be back in a day or two. Like I really need to chill.